Okay, good afternoon, Chicago. It's a beautiful, beautiful weather today. Well, I'm from Dallas, Texas, so to me, it's beautiful to me. How's everyone today? It's good? You get good lunch and everything, and good drink? Okay, awesome. So my name is Bryant, Bryant's son, or Bryant Jimin's son, because I'm Korean American. I'm a solution architect working for GitHub. I belong to expert service team together with some people here. So this session is called Get It Right. Get it right, get it right, get it right, get it right, you get it, right? So this session, I guess you will have another session after this from Andy. But you previously saw that one from Preston's session. Hey, there's Andy. Say hi to him. Say hi, Andy. So it's going to be an amazing session for him, his session too. So this session is kind of feeling like a one-on-one and two-on-one session. Like even if you're completely new to Git, you will get to learn, and then there's just going to be copy and paste. There's not much network required because I'm not going to use a presentation slide to drive things. You're going to get the website, and you're going to follow the instruction. But pretty much after that, you can get everything through the terminal. So they're going to be really like a low requirement prerequisite, but it should be really easy to follow along. So main thing for today is that, so first thing is, before you get started, and make sure that you're connected to the Wi-Fi. So if you didn't connect to Wi-Fi, I know it's like a Git Merge with a Wi-Fi name, and the password is a Git Merge 2022, all lowercase. So make sure that you're connected first, and then go to URL. You can visit either one, but I think this will be the shortcut that will take you directly to the website. And then, yeah. So I will give a few minutes. Maybe I'll play some music. I don't know how much time I need to give you, but I don't know if you can hear me, but come on. Okay, there's better music. Thank you. Okay. Make sure that you get the URL, type in, and get there. Let me know if everyone's good. Raise your hand if everyone's good. Okay, looks like everyone's good. Get pumpy. Cool. Okay. So once you get to the website, you should see a website looking like this. Okay, all good? So now, I guess I just want to kind of get a feel for just level set where we are. I just want to get a little idea where everyone stands. Please raise your hand if you're completely new to Git. Like, I don't know where to start. Oh, Prem, come on. I know you are you're like expert. Okay. What about you're like kind of a little beginner of the Git? Like, you know, like how to do stuff, create a branch, and then check out and all those things. But just maybe not completely new to all the advanced stuff. Okay. So about half of it. What about if you consider yourself as I'm expert, I know everything about Git, like I'm a creator of Git, well, there has to be Linux, Torvald, but raise your hand if you're thinking you're like an expert. Anyone? Oh, there you go. Also, I know you are. Yeah. So, when you go to this page, hopefully this is a nice animation, that kind of GIF, and there's another nice animation there. But if you scroll to the bottom of the page, you will see the place how you can navigate, right? It's a link that will take you there. So this, I'm not going to use any presentation slide. I'm just kind of jumping back and forth my page, website, and then terminal. In my case, I'm going to use Visual Studio Code, but you can technically use any terminal for that. So if you get lost, if you just scroll to the top, you can just click this, and they will take you direct to the home page, and you can scroll down and go there, okay? But there's going to be some navigation to get you to the next page if you get lost. So we'll start with the very first step, prerequisite. For this session, it's going to be super simple. If you go into the Preston setup, if you listen to Preston's session already, you should have already done this. This just requires you to install Git CLI, right? So it can be, if you're using Windows, you can just download it from this page. And if you're using Mac, that should be installed already. Or if you're using Linux, that should be installed already. So make sure that you open a terminal and type git -- version. It really doesn't matter, I think, what version you use, so make sure that you can see that, and when you type Git, you can see this command like that. So let me know if everyone's good there. All good? Because that's really the only prerequisite you need to have for this session. Anyone? All good? All good? All good? I'm assuming good? Going once? Going twice? Going thrice? Okay, great, great. Okay, so I think we'll be moving much faster than expected. Okay, so if you get lost, you can always visit and install and keep going like that. So editor is not necessary if you should, especially if you're using Vim or if you're familiar with Emacs or Vim or Nano or Atom. But for this session, we are going to primarily using terminal, whatever form it is. So because even if you are familiar with, let's say, Git Desktop, source tree, Git Kraken, we are primarily going to use Git CLI to do all the stuff. So that's where we are. So, but it might be making life much easy if you want to just do it through the editor. So, but once you're done that, you're pretty much done with all the prerequisite. So we'll move on along to the next section, which will get the actual fun start. So each section is breaking down into some of the concept, but like, and then I will talk the focus of this session a little later on. But I want to give like a little background. I know that some of you already know about all those things, which is fine. But I want to just make sure that at least let's talk about some of the basic command and things like that. So basic workflow. This is not just for GitHub or GitLab or Git Bitbucket. It will work for anything Git-related system. So in general, if you're working with the files and you're working with the Git system, technically there are different stages you need to be aware of. So as you start working with the file, if you don't say didn't modify any file, that is an untracked. So that file is not getting tracked. But as soon as you're modifying a file or files or directories, whether it is adding a file or deleting a file or removing files or whatever, that should be modified stage and that should be tracked. And understood? All good? And after you modify those files, you have a choice to add those files, which then becomes a staged environment. It goes to staged environment if we call that staged. What that is a stage for is for the commit. So all the things that goes to commit stage is whatever you added in the stage environment. Got it? So it's going to be modify, and stage it, which is we'll do with git add command, and finally commit, right? Of course, if you're working with the GitHub, GitLab, Bitbucket, it will be like pushing, which is network operation, right? Which we'll not do for this session, but I'm going to talk about it a little briefly. So there are Git user interface tools like GitHub Desktop, which is easy to use because everything at UI based, or Git Kraken or source tree or whatever. But technically, you can operate everything with the Git CLI, just Git CLI. So Git Pull, if you're checked out from or cloned from remote repo repository, you can do Git pulls to get the latest change. But for this session, you don't need to do that. And there's going to be Git checkout. This one we're going to use. Git checkout, whatever the branch name is saying that as long as the branch exists, whether it's from the remote, whatever you clone from, or sitting locally, in our case, in our session, we are going to only use the local branches, okay? So you don't need to worry about they coming from remote branch or whatever. So Git checkout branch name should be fine. And if you don't have a branch already, there is a way to create a new branch, just passing -b argument, and then that's new branch name and source branch. So typically it's like a main or master branch, and then the branch name is whatever the name that new branch is about going to be. And there is kind of, I think, with the later Git CLI, Git switch is available, which is kind of similar to Git checkout. So it's just to, I think, give like a more, I would say, from the name convention perspective, it makes more sense. Maybe instead of doing the checkout, is Git switch kind of do the little similar thing, but like a little more, I would make it more sense way. And I would just say, typically when I do teach Git and other things, I tell other people, whether it's a customer, or a user, or a developer, I tell Git status is your best friend. Every time you make some changes, do git status often as possible. They will let you check where you are, whether it's modified in the stage environment or the commit history stage or whatever, right? So git status, I see some refresh there. Hopefully it's good. Okay. So yeah, git status is something that they will let you where it is. Git add is one that will add it to stage environment. If you add and dot, they will technically add everything you modify, right? So be sure to use that as with the caution, okay? But we'll be more cautious for most of the sessions or in the exercise because it's going to be a very interactive session. We're going to do by one, which you can do by add a file name that you modify, right? This is how you can do it for multiple files. If you just want to do one file, you can just do it as it is like that. And supposedly, like let's say you modify it, and then you want to kind of, restore that which was not added yet. You do the git restore, which will just bring back and undo it, right? And then once you add a file, then you can do commit. If you just do git commit without passing any argument like -m, they will kind of bring in the Vim interface or whatever editor you set as default, which will be kind of a little maybe cumbersome. So you will probably, it's going to be easier if you just pass the message you want to pass as a -m, right? And git push, we are not going to worry about it because it's going to be network operation, but that's just kind of it is. And this is kind of how the Git work with the GitHub. And this kind of summarizes what we have talked so far, and then with the additional, I guess, git fetch, right? There's some information there, not necessarily relate to this session, but most of the stuff in command you see will be what we'll use most of the times for these exercises. So yeah, so I mentioned git status. Git status is going to be command we're going to use a lot. It will help to verify current state of the repository and the file it contains. Or if you just modify any file, they will show where it is. So let's try to remember that. Try to remember and think in your head, right? So for some of the exercise, we are going to work with the more than one branch. So if you do git branch, they will show, yeah, sorry, my voice kind of cut off a little bit. But git branch will show all the branches that you created or have in your, yeah, a little weird, but. And one other command we're going to use a lot is git log. Git log will show git history and then all the things with the commit IDs. And but one extra, well, I guess, argument we're going to pass is --graph --graph --all. They will show all the branches, and then it will show it in nice branch format, right? So we'll try to use that quite often. So just try to remember that. So any question? All good? All good? So because next section is going to be actual, going through all the exercises. All good? Okay. So main point or the purpose of this section is, to learn different ways to undo or invert, to change or reverse or reset git commit. There are different ways to do it. And this session will be focusing on different ways and mechanism and all the things to do with that. So we'll talk about briefly for each concept, and we'll go through the exercises. That's weird. Okay. Did I get just lost presentation slide? Let me try to plug in. Okay, weird. Hopefully it came back. Okay, all right. So yeah. So, and there's going to be one additional section called Git Bisect, little, I guess, diverging away from the main topic, but we'll talk about it at the end. And supposedly we don't go through all the exercise today. That's fine. You can take it and you can finish it. All the instructions should be there. Yeah. Yeah. So how commits are made? Just every commit is a unique snapshot of the project at that point in time. It contains the following information, like a pointer to the current object in the repository, commit author and email, commit date and time, and commit message. That's just a kind of quick 30-second overview of a Git commit, right? Weird. Well, I don't know why it's refreshing so often. Weird. Okay. And yeah, so Git data structure gives integrity but distributed nature also requires to be aware of how certain operation will impact the commit had already been shared. If your operation will change the commit ID, then when pushed to remote, also known as public commit, we must be careful in choosing the operation to perform. But really the main thing is we're going to go through all this command, Git Revert, which is instead of removing existing commit, it is undo or revert the change or invert the change by creating new commit. And then we're going to move on to commit -- amend. It's a really convenient way to modify the most recent commit by combining change with the previous commit. This is really useful. Let's say I commit something, but the message is wrong, and I want to kind of, or edit, I forgot to add a file or whatever, right? It's really good for fixing the change you just made, right? Cherry pick. Cherry pick will be really useful. Let's say you're working with somebody and there's a main branch and somebody else is working with another branch and they want to pick that interesting commit in another branch and bring to the branch that you're working on. So it will be nice ways to bring that specific one. That's why I call it cherry pick. Rebase and squash. So rebase will be the ways to kind of say bring by default. It will be ways to say I would like this kind of git commit history from one branch, and then want to be kind of bring in and merging into adding to the tip of my current branch or the branch I'm working on. And there's ways to be more specific. One concept we're going to explore is a squash. You probably heard that a lot, squash. And then we'll see how it can do it interactive way. And then when you reset has to be definitely taken with a caution because it can be destructive or most destructive. Good thing is that there are going to be 3 ways to do it: soft, mixed, and hard. And we're going to all see the other way, but you will see how it's going to work. So those are going to be the things and there are going to be additional Git Bisect section. Okay. So let's start with Git Divert. So Git Revert, as you can see in this diagram, it works by, it's the safest operation because it doesn't modify any existing or previously made commit history. Yeah, I don't know why I keep refreshing, but yeah. So instead, it will just change whatever the change you made, and it will try to make a new commit point to undo the change you just made. So for this, in any exercise we're going to do it later, it's going to be kind of using the same process over and over again. You can technically use one directory to do everything, pretty much, but like we're trying to create a new directory every single time. But however you want to do it, it's really up to you. I just wanted to make sure that everyone in the clean slate, so you will just create a new directory every single time and copy and paste, so it's going to be the same operation over and over again, right? So very first thing to do, make sure that you open up, if you're using Mac or Linux, open up terminal window, and then make sure that you create a maybe new directory, so it's easy to just go right into that, right? So if you're creating home directory, maybe it's hard to find it later, so maybe it would be nice to create a new directory, right? And if you're using Windows, assuming that you install Git CLI, open up Git CLI, and that should be allowing you to run most of the shell script. We're gonna mostly going to be automating the process. Make sense? So very first step, you can just copy and paste. I'm going to create a new directory, and then going to be the Git Revert demo. And I'm going to using this Visual Studio terminal, but you can use any terminal. It will work the same. I'm going to just paste it. That will create a new directory, and I can go inside there. And so I can just start from there. Right now, it should have nothing there because nothing was initialized, no file was added. So that's the where we start, right? Where we can start, okay? So now going back to the second step, we're going to create a new shell script. It's called the generate Git single branch. It's for only one branch. So, and then you can create it however you want. It's up to you. But I'm going to just use this touch command to create a new file. If you're using the text editor, you can just right-click, create new file, as long as the shell script should fine. But make sure that you can, right now by default, it should not be, hold on a second. By default, it's not executable, so make sure that you can make it writable with that. So after that, if you do that, it's now executable, okay? Now try to open that file, where is it, a text editor or however you want, but I'm gonna use a Vim or VI or whatever you want. I'm gonna open it, and there is gonna be some pull script. You just select everything and copy it and paste it. Again, how I'm gonna save the script is up to you, but this is, I'm going to be using Vim, so I'm going to you can use a W cube. I really like exclamation to save. So I'm going to just save that. So that's just the shell script got saved. So now I have this one file there. I'm going to execute this by running this command. And that will initialize this directory as Git directory, okay? So now if I see what is in there now, you'll see .git. That's going to be where you're going to track in Git, and then there's additional readme.md file. And quick other way to check, you can do git status. We're not going to use this again, so you can ignore it, because it just helps to generate. But you can check what is the content in the readme.md file, and then I explained that you're going to use this command a lot, git log --grep --all. That will show, and to way to get out if you get stuck, if you hit the Q, that should be let you get out from here. But this will show from the bottom to top, and the top one should be the most recent commit. And it should give it generate some commit by itself, okay? Just with this script, okay? So what we want to do is that we can try to revert this one, but instead of doing that, we're going to just make it so everyone's easy to follow that. We are going to just modify our generated file, which is readme.md file, and then create a new commit with that and revert that. So you can I think that's an easier way to understand and then see what is going to change, okay? So right now, if you look at the readme.md file, that should be there's only 3 sentences there. So what I'm going to do, I'm going to go to my last line. I'm going to say, welcome to Git Merge 22, and then this is going to be awesome, right? And that's going to be it can be any change, but that's going to be my sentence. And I'm going to save that. So remember what I told earlier, that Git status is your best friend. I'm going to type Git status. And then as soon as I've done that, it's tracking what I modify. So it's just showing as modify, okay? All good? And yeah, then I'm going to do git add and readme.md file. And then when I do git status again, now it is in the stage environment. Make sense? So then I'm going to make a commit. Later, I'm going to kind of switch it back and forth how I can do add and commit a single sentence. But right now, I'm just going to in 2 different steps. But I'm going to say this is going to be a revert operation. So I'm just going to be passing commit message, okay? So now, once I've done that, if I check this log --grep, we're going to use this a lot, so be used to this. And you see there's going to be the latest commit that I made, right? Now, let's say I want to leave with that. I want to throw it away. Now, with the Git Revert, as mentioned before, you will be able to it will not remove the previous, and it will not affect any previous history or Git history. It will be able to do it just by creating new commit, okay? So I'm going to copy that. And I'm going to do Git Divert and that. Then it will bring up this, and then of course if you pass -m message, you'll be able to do that. You can modify this message however you want. I'm going to say this is going to revert. Okay. And I'm going to save that. Now let's see what happened. Now if I've done that, if I look at readme.md file, it kind of went back to where we were before. So it just reverted the change we just made. Okay? But if you recheck the log history, it didn't change any of the existing history. Instead, what it would done is that it created a new commit and then just did it by revert. Make sense? Any question? Any concern? Anyone got stuck? All good? All good? Okay. Yeah. Good. Cool. Again, the way to get it out, if you get stuck, just hit the Q button, and then that should be good. Okay. Now we'll be going. Oh, one thing I think forgot is that so it's in the instruction. So now what happened if you do revert back the previous commit and after already some changes are made, right? What is going to happen? Just let me quickly show how it's going to work. So now, let's say instead of doing the very top one, I'm going to pick somewhere in the middle, like this one. Let's try to revert that and see how it's going to be different. Okay? So I'm going to grab this one, and I'm going to revert and see how it's different. Okay? And some more change. And change. So now, if I try to modify that, actually there's one thing I need to do. Actually, let me try pick the other one. Okay, let's try to pick the one at the little more at the bottom, like maybe this one, and see what's going to change. Okay, I'm going to copy the one at here, and then try to revert that. So now what's going to happen is if you already kind of made change it to the one that already committed and then way at the bottom, this will result in the merge conflict. Okay, this will result in the conflict. So if you check your readme.md file, you have to kind of modify these changes and then make sure that those things are resolved before you commit and merge. Okay, so this will result in the conflict. So you need to make sure to resolve that, right? So I'm going to just remove that and then see everything is good. And then just going to be saving that, and then it should be good to go. Yeah, and then I can do that add. And okay, so one thing I want to show is that let's say I want to do everything in the one line. You can do git add readme.md &&, and then you can just do pass the commit message and then fixing the conflict. Now. Yeah, so, and then git commit, and then that's done. And now if I check, yeah, that should be reverting by adding one more commit. All good? All good? Great. So now we will start creating new directory. Right after this, we're going to do this kind of same pattern over and over again. So hit the cd ... So go to one directory above, because we're going to create a new directory every time. I mean, it's up to you how you want to do it, but this will help you to start with the completely clean slate, right? Okay. Now, I will go, and then we can go to the next section. So this section is going to be git commit amend with extra git commit amend, right? So previously, you learned about git divert. So git commit amend, -, amend, is part of git commit with the extra parameter, right? It will make a change by, let's say you made the commit already, and you forgot somehow your commit message is somehow, right? Well, it's not right. Or maybe you realize, oh, I forgot to check in some file or made a few mistakes. This will help to modify existing commit you just made to fix that, okay? So that's the purpose of it. So same step, kind of similar, almost the same step. So I'm going to create a new directory, and then cd into that. Okay, so now we're in this directory. Okay, I'm going to create a new file. Just going to copy that, and then I'm going to make it executable, and then so it's executable now. You can see it by X mark, and then I'm going to I'm going to populate the content with here, this script. I'm going to just select everything. It's going to be exactly the same script we used earlier. So paste that. So again, I forgot to kind of walk through what this one does. It's a shell script that basically initializes as a Git directory, and then it's going to check out the main, and it will be creating a file, readme.md file, and it is going to modify by adding a few sentences and make a commit. So it's just simple one single branch operation, right? I'm going to save this. And again, same step as last time, I'm going to run this script, which will generate Git history. So yeah, so you can see .git, which is tracking, and then that same readme.md file you saw earlier. So now, if you go to the previous step, exactly the same step, we are going to purposely make a typo. And then technically, you can use any sentence you want or any change. But we're going to just, for the following this, we're going to copy that. And this sentence is wrong because Git Revert is the best way to make changes without rewriting history. But we'll just use that for that now, right? So I'm going to modify readme.md file. You can put this anywhere, but I'm going to put it at the very bottom of the line. I'm going to commit this and change, and then commit and purposely making a bad commit. Okay, so now if I do see the history, you will see that this is there, and I want to change that. Okay, so I'm going to do it by Git readme.md, and I'm going to, so first thing is remember that where we are. I think the important thing is to remember, so the very last one you see is that purposely making bad commit. This commit is going to be changed with the whatever we are going to be amended with, right? And then, so this is the very last one, and the one before is adding some more description, okay? So see where the top one is and see where the next one is, right? I'm going to make it one change, and then I'm going to say it's not Git reset, it's a Git Revert. So I'm going to save that. And then I'm going to git commit amend, and then do that. Then it will try to revert last whatever the change you made. So I'm going to say this will fix with write operation for Git, or whatever the commit you want to make. I'm going to save that. So now, if you check your readme.md file, of course, it's going to be the revert is the best way to make, and that's content-wise fine. But interesting thing is, if you check the log history again, remember where we were before? This was the one right before the top one, right? Now it's replaced with that, with the different git commit message, and then that should be the one that modified. Any question? Anyone following? All good? All good? Checking? All good? Okay, great. All right, so that kind of wraps up for this one. Now we'll move on to the next section. So cherry pick. So cherry pick, as you can see, is picking like a cherry in the tree. You can pick the exact one that you want to do it and apply to the other branch, okay? So cherry picking allows to pick a commit from the leaf log or another branch of a project and move it into your current branch. It's a very powerful command, and that allows specific git commit from reference and append to the current working head. So some of the reason why where cherry pick will be helpful. It will be that whenever somebody else accidentally made a commit to long range, right? So you want to bring that change to the current branch. Or your team needs that specific change, where it's a new feature or a fix, and maybe somebody else, okay? So it will help you to do that. I think I need to modify this, but yeah, so cherry pick. So it's going to be the same step. So we're going to be going one more directory at the top. So we have just two directory now. We're going to copy that and make a directory and cd into that. Exactly the same step. Okay. Okay. Yeah. So now this one is a little different script, but kind of same type of pattern. We're going to create a new script that create multiple branches. Okay. we're gonna make that touch, and then we're gonna make it executable, and we are going to modify it, and then go to the here. So this will be making 2 branches, and then there's only test.java file in the test branch. Okay, so I'm going to paste that. So just kind of walk through a little bit what the script does. It will initialize it as a Git, and then it will get from first thing is it's going to stay in the main and then creating main.java, but it's going to check out and create a new test branch, and then add test.java and modify a few stuff, and then we want to change it back to the main and then modify the existing main.java, okay? And then, so what we are going to do is that we will bring that change, because test.java is only existing in the other branch, test-branch, we're going to bring that change and apply to our main branch. Make sense? Okay? So there's where we are. Now we're going to, just like last time, we're going to run the command, initialize it. So let's check a few things to make sure everything's good. ls-la should show hidden file including .git. Again, this has a main.java, so you can check the content if you want. So just a simple Java main class file. But this one has more than one branch, main branch and test-branch. Let's check out to this test-branch and see how it's different. Now, if you do ls here, you will see main.java, test.java. So you can see the content for test.java, right? And you can see the content for main.java, just to checking. You see this is kind of a little incomplete in purpose. But now let's just, and so we are at the moment, we are in the test branch, okay? And also you can check git log -grep -all. Remember that we're going to use this a lot, right? So you can see that this is a main branch, but now you can, because you pass that -all, it will show the other branch, which is test branch. And so yeah, this will be the one that we want to cherry pick. But so you can see that this is a main branch and this is the test branch. So now, so yeah, so you can check with that operation. So now let's try to cherry pick. So let's say I want to cherry pick one here. I want to bring the latest commit from the test branch to the main branch. Okay, makes sense? So once you do this again, just to show you, so everyone following, when I do run this command, I want to pick this latest one. Supposedly that's the one I want to pick, and then copy that. So I want to bring that test.java into my main branch. Okay, so copy that, and I'm going to check out to main. I'm going to do the cherry pick, and then do that. So it will resolve some conflict, but now when I do ls, remember that in our previous example, when I do ls, in the main branch, didn't have that main.java, now it does, okay? And then also, so it brought from the test branch, and so it's there, and then it is maybe have some conflict in the main.java, so if it does have it, it will fix it, but otherwise, it should be good to go, I think. Yeah, I think that should be a git status, and then you can see that it can add and delete, and then, yeah, and then git commit. Let me clear the screen a bit. Git commit -m, and then may brought a commit point from test branch. Yeah, and then, yeah, so now that's in our history. So, yeah, so this is the change that apply from whatever you cherry pick from here to here. All good? All good? Makes sense? So that's it for cherry pick. All good. Now we'll go just prepare for next section. We'll go one more directory up top, and we'll start from there. Okay. So Rebase. Rebase is interesting. So cherry pick allow you to pick that specific point in other branch and bring that over. Rebase will be, by default, there's another option, interactive option, and many option you can do with it. It does give you a lot of options. Rebase, by default, we're trying to bring all the commit and then apply to the tip of the branch that you have, okay? Makes sense? And I'm going to talk about Git squash option, which will be the one that you will see when you do interactive rebase. Yeah, all good? So rebase enabled to modify your commit history in various way. You can see the diagram. So whatever it is in this diagram, you see that there's a new branch, and then we can apply and then to this the dead branch, right? So rebase comes in several forms. In this section, it's for basic rebase by default, and then rebase with interactive option, and rebase with the squash, right? So why would you want to use a Git rebase? The goal of a rebase is similar to that of a Git merge. Like if you do Git merge, that's like a merging from one branch to another. They're both trying to integrate one branch to another. But now if you're using web-based Git platform like GitHub, GitLab, or Bitbucket, you might be familiar with the concept of pull request or merge request. So that's kind of like doing the merge. But anyway, Git merge or Git rebase provide a similar way to merge with one branch with another, but through the plain simple Git way, okay? Merge works by creating a new commit in destination branch by tying together the history of both branches, and is a safe operation. Rebase, on the other hand, moves the entire commits. So though there's a selected way to choose to the tip of this, and then there's a selected way to choose to the tip of the destination branch. And this is essentially writing the project history. So have to be a little more careful, okay? So same exactly kind of pattern. We're gonna do create a new directory and cd into that. So we are in this directory now. Of course, there's nothing there. And we're going to create just the same script we used before. So if you're comfortable using the existing directory, that's perfectly fine. I'm just going to create a new file and then make it executable. And then I'm going to modify that and copy that. Paste it, and again, this is exactly the same script last time, just creating two branch, main and test branch, and then some Java class files. Save that. So I'm going to run this to generate. So exactly same thing as we saw last time. Yeah, so same structure, okay? Hold on a second. Okay, same Git structure. Now, where we want to go is that, so we were checking out to the test branch. So this is a branch we are in right now, is the main branch. We will check out the test branch, okay? Git checkout, test branch. Oh, before that, so if you do ls, you can see just one file. We did explain earlier, but just to make sure that, it's going to be different. Check out test branch. And then now if you do ls, it will have an additional file, so a little bit more difference. Now, if you want to, from here, so before doing anything going further, make sure that we can monitor what is like right now. So very top of the the main branch is close main.java. Main.java. That's what we see in the main branch, right? That's the tip of the main branch. For test branch, you see that add the main under test.java, add a class to test.java, and a new file called test.java, right? So that's going to be if we do rebase by default option, all this history and commits is going to be coming from here and apply here. Make sense? Okay. So you will see that. So I'm going to git rebase and then to the main. It has a default option. Okay, so done. Now, if I check history, well, before that, let's check the file. So right now is this a test.java, but let's check out the main to check. So now if we check the main, you see that it's there. Let's see, git log. grep, all. So you see that this is actually the main branch, and then this is actually applied from the test branch, and then applied to here. Okay, makes sense? Okay, and then git status, and then yeah. So that's that. So now that's the default option. Now let's try to reset everything. So I want to show you one more option, which is the interactive option. Okay, let's see how during time. 3:14, so maybe a little more time. Okay, yeah. So I'm gonna be, actually well, I started 2:45, so it should be fine. Yeah, so I'm going to reset everything. So by deleting .git, okay, I'm going to deleting Java file. So I'm at the clean slate, okay. I'm going to regenerate. Same structure, okay? So I'm at the very start. So this time, what I'm going to show you is that I'm going to give you, so we're going to do just like last time. We're going to check out the test branch. So I'm in the test branch now. So I'm going to do with the now rebase with the interactive option, and pass -- interactive, okay? And then do the main. So this will bring more, I'll just say, choice. Instead of picking up the changes that bring everything, this will give more option. So this is where we will apply squash. So if we do squash allow you to combine multiple commits into one or few commits, okay? And you can see there's other option there. So I'm going to just combine the other two with this one, okay? So it can be into one single commit. So I'm going to change that, pick in the last two to squash, and then leave it there like that. All good? I'm going to save that. Yeah, so now if I do git log grep all, now you can see it brought the changes from test branch, but it's now combining those things into single commit. All good? Anyone's good? Just checking, I guess. Yeah. All right. You guys are awesome. So I will prepare for the next section again by going into one more directory at the top. Yeah. So you can read and follow. All this instruction is here. Yeah. So reset. So reset, I explained a little earlier, it can be most destructive in terms of history, so have to be careful. Good thing is that it provided 3 different options, one for soft, one for the mixed, which is default option, and then one is hard, which is the most destructive one. So it does it by, like this is like it's where it's head, he does by resetting the head, where the head is, right? So again, I explained at the very beginning that how there's different stages, different phases of git commit or git in general when you work with the git. There is a working directory, which is when you start working, and then that's when you modify, untrack, and then whatever. And then when you do git add, it goes to staging environment, which is then ready for commit. And then there's commit, when you do git commit, it goes to git commit history. So git reset soft, which is passed by -- soft, can revert back to only that commit one. It will not modify the whatever you edit or modify. It will only revert the commit itself. Okay? So it's safe in some sense. And it can be more destructive and go down below. And the mixed, or by default, if you choose to git reset, it will be removing the commit, and also it will remove the whatever you added, which is in stage environment. Lastly, reset hard will be the one that actually remove everything. So if you did modify, this will technically remove everything, right? So that's what I mean by most destructive. You might lose all the changes. So, so let's do the same exercise, similar exercise. I'm going to create a new directory. I'm going to go to that, reset demo. So I'm at the clean slate. And I'm going to, again, same thing, same exactly script as last time. So I'm going to touch that, and then going to make executable. And I'm going to modify that, and then copy and paste this script. This is exactly the same script as last time. So save that, and I can learn to generate this. So all good. Okay. So again, you can just check your structure of your Git history. All those things exactly the same. And then now let's do the git reset soft. So that the Git ID or SHA ID you're picking from is not the one that at the top, because that's going to be a current one. You will pick the one that happened earlier. That's the where it does revert to, like a kind of time travel in a sense, right? So let's try to pick something that maybe happened one before. So if I actually, let's just show you what it looks like. If I pick this one, it will not do anything because that's going to be the current state, right? But so I need to pick that one happened earlier. I'm going to pick this. I'm going to git reset soft. So now when I do this, what's going to happen? It didn't remove that one that happened earlier, right? Okay. But now, good thing to check is that, so now when I do git status, this was committed, so it was now in the stage environment, right? But the file itself also is not modified. Make sense? Yeah. So this soft reset will only remove the commit, and then bring that commit one to the stage one. Okay. And now let's try to do the default option. So now if I do, let's pick the other point. I'll pick the one below this one, okay? So let's do that. And then I'm going to, so you can do either of way. You can do by default, don't pass anything, or you can do mixed. This is exactly the same thing. I'm going to do that. So really different about this time is that actually that it did become unstaged, meaning that this file was previously edited, then now is not staged. If you do git status, well, now is not edited anymore. However, the file itself is still the same, okay? It does not affect the file you modify. Lastly is the, let's pick something else. Let's pick something that here, the one right before. Now we'll do the most destructive operation with the heart. This will be removing all the changes. So when I do this, if you check your commit history, not only it did remove and revert it back to the point where I specify, if we do git status, it will not show anything. And then if I check my file, it was, remember that it was a completed curly braces and close braces, all those things. Now those are gone. So this will be most destructive in sense. If we didn't work on it and do that, it will be technically revert back the entire thing. So, yep. Any question? There's all the things there. Any question? Any question? No, good. Just checking, making sure. Okay. Okay. I think this is the last section, so I think I'm good on time. So yeah. So Git Bisect. So far, what I kind of walked through before is all about how to revert or undo the operation, invert the operation. This one is more like a user tool that will help you find out that very bad commit or the commit that you're interested in, and then somehow it was whatever it did, it might be broken your environment, or it might be something that some other, maybe your friend or coworker or developer made, and you want to find them but not sure how. This is kind of doing something called an operation called binary search tree. If you did a computer science, you know how it works. It kind of broke down into two, and it keep breaking down, and then to find that specific point you need to search for, right? So yeah, so where this will be useful is when you find a bug, but you have no idea when it was introduced, when a new feature got introduced, but have no idea how to trace back, when there's performance degrade or improvement, but you have no idea how to trace back. So this Git Bisect is the built-in option in your Git CLI. This is a very nice tool. And way to start is really easy. You do Git Bisect start to start. And then if you want to end it, you do the Git Bisect reset. And then you then mark whatever you think it was a bad, which is probably at the latest one, and then mark it as a bad bisect. And you mark whatever is good, which means that before that the bad change happened, you mark that point, which happened somewhere earlier, as good. And you keep investing it by doing Git Bisect good, Git Bisect bad, and checking that to narrow down to the point that we actually find a bad commit. Okay? So let's try to do that. So that's the concept. I'm going to create a new directory again, going in one more top, and do that, cd git bisect. So this one, compared to other exercises, will be requiring 2 scripts. And then so it's going to be the only one that is a little different from the exercise perspective. You have to run 2 scripts, one at a time. So I'm going to copy this. It can be whatever name you want, but this is going to be the name I'm going to create it. Again, remember that how you can create a file. I'm going to touch this file and make it executable. Okay? And then going to write, or copy and paste this first part of the script. Is about the description about Harry Potter book. Okay? So it's going to create a file called the book -Harry Potter.md, and then it's not actually a Harry Potter book, it's just a description of Harry Potter book. So it's, yeah. So I'm going to learn this first part of it. And then so when I look at the history, it's going to be all the way up to 7 sentences, okay? And then when I check the file, it's going to be looking like this, okay? All good. Now, in somewhere, I'm making it really obvious for everyone, but it's not going to be a case if you're actually working with something like this. I'm going to intentionally make a bad commit and bad like a change that will be obvious right now to us, but this will be like not so obvious when you actually work in production environment, but I'm just intentionally going to make a bad change. So I'm going to modify this file, which got created, and maybe go all the way to the bottom. And it can be anything that you want to make it. It doesn't have to be this sentence, but the sentence I'm going to use is Harry meets Darth Vader, which is a totally out of scope. Is a Star Wars reference. Yeah, and you find that he's a lost son of a Darth. Yeah, so that's going to be a bad commit, right? And then I'm going to save that and add, and then git commit -m, and then intentionally make a malicious commit. Okay, so now if you look at history, of course you will see that it's obvious this is going to be the bad commit, but in the real case scenario, you're not going to be figuring out what exactly the bad commit. Okay, so now as a next step, we're going to create this second script, post-generate Git Bisect, and so we're going to do that and make it executable, and we're going to modify that, and then I'm going to copy and paste this. We're almost done. This is the last exercise. And then I'm going to run this script. So this will add additional stuff. So now if you look at our, first thing, let's check out the file. Let's check the file. If you look at this MD file, you know that somewhere you're like, okay, I see this and this doesn't belong here. In your case scenario, this might be bad commit or bad codec one that breaks code, or it might be even like vulnerable code. And you know it happened somewhere, but you're not sure how did it happen or when did it happen, right? But you know this is a bad change. So, and the purpose or our mission is to find that when did it happen and do something to fix it. So of course in the history right now it's obvious this is going to be the bad change, but let's say we assume that we don't know where it happened. Okay, this is where the Git Bisect will come in handy. So I'm going to start bisect by doing bisect start, and this will start our Git Bisect. So I'm going to look at my graph again, Git log history again. Typically, if you kind of can guess when was that last time, or when was the very first one that didn't you didn't see any major change happen, you can guess that, right? But in my case, let's say I have no clue where that happens. I'm going to say that I'm going to pick the very first one that I know that at this point, something bad didn't happen. So I'm going to select that, the very first one. I'm going to mark it as bisect good, like that. And then, so I know that I don't know where this when it happened, was when the last bad change happened, but in this scenario or in the use case, I know that it happened somewhere at the end. So I'm going to pick the top one, and I'm going to mark as bisect bad. So what's this one doing is that it's actually going to break down into health, and then you see this is somewhere in the middle, and it will try to do and you can decide where to go to the next one or the one before by looking at it. Is this a place where does it have bad change happen? So now let's check. Let's say look at our file. I still see that the bad change. Let me see. Yeah. No, I don't see that the bad change, right? So in this case, I know that so it didn't happen in the sixth sentence here. It didn't happen here. It has to go a little further in the timeline, right? It has to be somewhere after that. So after this point, so I'm going to say bisect good. This will be moving forward to where you can see the sixth sentence is after that. So then it goes to the next one, break down into further health, and then go to the next one. Now let's check that file again. Hold on a second. Okay. So now when I look at this file, I can see that this is there. So I know that it happened somewhere between that. So then I'm going to say git bisect bad. And then I'm lucky because I just found it right away. This is exactly the best change happened. So it was kind of narrowing down by breaking down into health, and then pick somewhere in the bottom health, and then I say it's a good, so you go to the next one, and narrowing down further and further to get the pinpoint that bad point. So now if I check that here, I know that this is exactly where this bad change happened. So I have a few choices after that. There's our bisect command, additional command you can use to troubleshoot and fix it, or you can just make an additional command to fix it. I'm going to select the easiest option. I'm going to just reset to get it up, and I'm going to know that this is a bad change. So I'm going to remove that, and then gonna fix it by, and then fixing it by fix the bad change. So yeah, so Git Bisect, as you can see, it will be a really useful tool, helpful tool to find out that exactly where the bad commit or whatever the bad malicious commit happened and help to troubleshoot. And that's pretty much it. I think I'm right on time, lucky me. Yeah, so yeah, and this link should be available to you to follow afterward. So yeah, this is who I am, and then yeah, so you can read, and then this is some of the link you can follow me or the YouTube, Medium, whatever. Yeah, but thank you everyone in Git Merge team who give me an opportunity to take in this workshop, and Lali who helped to set up and everything, and then my coworkers, Prem and Andy from there. Okay. And Preston and Andy somewhere. I know he was in there. Yeah, to our wonderful coworker in GitHub, and then expert service team who helped to review the content and give a constructive feedback. Last but not least, thank everyone who attended this event. Thanks so much. Yeah, that's it.